If you wish to reshape a data frame from wide to long format by unpivoting selected columns into rows, you can use melt functions in pandas. This will be useful for data normalization and preparing data for analysis. So this wide format can be transformed into long format by using the melt function in pandas.melt. The melt function has many parameters, including frame, ID vars, values, and so on, and you will see one after another. Let's start to see the frame parameter. The frame parameter accepts a data frame to be melted. ID vars. The ID vars parameter specifies which columns will remain fixed or as identifier variables, while others are melted or unpivoted into rows. And this ID vars takes a scalar, tuple, list, or n-dimensional array, and it is optional. So when the ID vars accept a scalar, for example here, name is a scalar or a single column used as identifier and remains constant as other columns are unpivoted. Each row in the melted data frame will include the name, the subject, and the corresponding score. Let's create a data frame to see. So if we create this data frame, let's first import libraries, pandas and np. We import pandas as pd and numpy as np. Yeah. And then we create a data frame. And you see our data frame is created, our data frame df. So when ID vars is used as a scalar, we can, the ID vars here, a scalar, a name, a column name. If we run this, we can reshape our data frame from this wide format into long format, and the ID vars here is a scalar will remain fixed. So ID vars can also receive a tuple, and when it receives a tuple, both columns will remain constant, while the tuple is used as identifiers. And each row in the melted data frame will include a name, year, the subject, and the corresponding score. So let's create a data frame to demonstrate this. Download the ebook. I have put the link in the description. You can download the ebook in order to follow along. All this code are found in that ebook. So if we create this data frame df and try to use the id vars as tuple, we can reshape the data frame into long format as this. When the id vars is used as a tuple, as you can see here, the name and the year, we can reshape from this wide format into long format. The id vars could also accept a list. For example, here, name and year could be used as identifiers. All specified columns will remain constant, while the remaining columns are melted. Each row in the melted data frame will include the name, year, subject, and the corresponding score. Now let's create a data frame so we could demonstrate how this id vars, when it receives a list, works. Okay, we use the same data frame we used to demonstrate when the id vars accept a tuple. For a list, it works the same and the result the same. As you can see, it succeeded to reshape a data frame from wide format into a long format by using a list, name, and year. So when id vars accept n-dimensional array, for example here, np array, the n-dimensional array for a name and year. This name and year will be used as identifiers, and both columns will remain constant, while the other, and both columns, the name and year, remain constant, while the other columns are melted. Each row in the melted data frame will include the name, year, subject, and the corresponding score. So we use the same data frame to demonstrate this id vars as n-dimensional array. So from this data frame, the id vars can also accept the n-dimensional array, as you can see here. The id vars has accepted n-dimensional array for name and year, and the output is the same as when we did for tuple and list. So this reshapes a data frame from the wide format into a long format. So when the id vars is not provided, when the id vars is optional, all columns are treated as variable columns to be melted. So when pandas.melt, when id vars is not provided, you see all columns are treated as variable to be melted. The name, the year, the math and science have been treated as the columns to be melted. The value vars parameter, this will specify which columns to unpivot, and it can take a scalar, tuple, list, or n-dimensional array. This parameter is optional. If we just want to specify a scalar, a single column to be used as a variable to melt, then the value vars can accept a scalar, and the metadata frame will include name as the identifier and mass scores as the values. If you specify the value vars as mass. So let's create a data frame, or we'll use the same data frame to see how a value vars can accept a scalar and the output. From this data frame, we can use the value vars as a scalar and mass the data frame is not compatible. Let's create a data frame here, df. This will bring the intended result when value vars accept it as scalar. And if we run this, let's try this. We forgot to write the pandas.melt. So when the value vars accept a scalar like math here, you see the value vars can accept a tuple, for example here, math and science, and you can melt this math and science into one subject column with the corresponding score. So the identifiers columns name and year remain fixed, while other math and science will be melted into one subject column. So we use the data frame, this data frame. So our tuple, value vars math and science, will bring this output. From this data frame, if we use the value vars as a list, we can reshape our data frame as shown in this screen here. The value vars accept an n-dimensional array. We use the same math and science to format into long format, from this wide format into long format. So we unpivot this math and science, and the data frame will contain the output just as we did in when the value vars in the last example, when the value var accepted a list or a tuple. So let's see. So this data frame can be formatted into long format by using the value vars, the n-dimension array. Here the n-dimension array will contain two elements, math and science. So if we run this, you see we can reshape our data frame by using the n-dimensional array in the value vars. So if the value vars is not provided, when the value vars is optional, you can see the output when the value vars is option. Let's see. So when the ID vars is optional, you can see the result, how the format would be. If you want to specify the name to use for the variable column, then the var underscore name parameter comes into application, and this var name parameter takes a scalar, and by default it is none. So here, if we provide a name, a variable name, let's call this subject from this data frame wide format. If we unpivot it into a long format and use math and science as a value vars, then the variable name, you can specify any name that you please, but here we use the subject to represent the melted math and science. So from this data frame we can use the variable name as subject, as you can see here. So if you comment this, you will see the subject become a variable. So this is useful when you want to specify a name for the melted columns from the wide format. So here if you comment the variable name, if you uncomment this and make your name a subject, it becomes like this. If we want to specify the name to use for the value column, for example here, the value name parameter will be useful, and it takes a scalar, and it is default, and it default to none. So to specify the name for the value column, we use the value name parameter. So you see when the value name is provided as a score, let's try to use the value name as score. You see, what if we comment this when the value name is not provided? You see, the value becomes the name, but if you want to specify a different name rather than this default value, you write the name that fits or suitable for your output. So here the value name we specify the value name as score, and instead of value it is replaced by the score with a multi-index columns. Then a column level parameter can help us to melt that data frames, and this column level parameter takes a scalar and it is optional. So if we have a data frame like this and we want to melt but at the column level 0, here it's Deborah and Fred, we will call them the variable name as name. So at the 0 index, the column level 0 is for this Deborah and Fred in a multi-index, and 1 is for this math science and math science. So to do that, let's create a data frame and then try to use the column level parameter. So you can see here the column level 0 is for the Deborah and Fred, which are names, and we have called the variable name as name. So this is how we can use a column level to unpivot to melt a data frame from the wide format into a long format. We can also use the column level 1 here from this data frame. The column level 0 was Deborah and Fred, but column level 1 here can be here it is a math science. This automatically we call them subject as a variable name. So column level 1 we contain this math science, and we can call the variable name subject or whatever the name you please. So let's see directly in the code. So this was for column level 0 from the data frame. From this data frame, for column 0 we specified the name Deborah and Fred, and you see in the output on name Deborah and Fred and the corresponding score. So here if we specify column 1, you will see the name changes into math, science, math, science, and so on. So you can use any column, either column 0 and 1, to specify the column level from this data frame. So the last parameter is ignore index parameter. This parameter, it helps to retain the original index or to ignore. This parameter, it is a boolean and it defaults to false. So you can ignore the index in the output, or you can retain it. So let us see how it works. In this example here, when the ignore index is true, which is default, you can see the output index is ignored, because ignore index true. That means we ignore, instead of having 0 1 2 0 1 2, we're having 0 1 2 3 4 5. So here the original index is ignored and the new sequence index is generated, as you can see here, 0 1 2 up to the 6th element, the 6th row, or the 6th index. So if we write, so for this data frame, if we use the default value true, the ignore index is true, you can see here the new index is generated, 0 1 2 3 up to the 6th index. But if you use false, you will see that the original index is preserved in each row. For example here, see 0 1 2 0 1 2. So this ignore index helps us to deal with the index in the output. If we want to preserve or retain the index, we can say the ignore index true. But if you want to preserve the output, you can say the index false, ignore index false. If you want to generate a new index, we say ignore index true.